Okay, hi everyone. This is talk Introduction to Nushift. Let's go to there's my master. Let's go to the next slide. Okay, so this is a modified version of a lightning talk I gave at SID.js. It's even more cut down. And this slide at SID.js, sorry, let me just look at the time. All right. This slide at SID.js I actually called my journey into programming, because it's more of like a LinkedIn core meetup than this one. But at this meetup, I'm calling it Some Motivation. So the first like programming language, things that got me into programming was JavaScript, browsers. And the cool thing about it is that you can share your programs with anyone. Like other kids who were into programming at that time, they weren't doing like web, they weren't just like systems, languages and stuff. But like, you could never run their programs. So like the web was like way better in that sense. And so my thing is, why it's been like 30 years that we've had the web, and a lot of people have started other platforms in that time, and companies have started based on starting a platform and saying everyone come write apps for our platform. But none of them have it as mobile apps, for example. I mean, it's not really a particular company, but none of them have had the feature of being able to share a URL to your program. And my question is why, outside of academia, this has been done a lot in academia, but outside of academia, basically no one has done this. Almost no one has done this. So yeah. So Nushift is an attempt to be an alternative to the web that has these advantages of the shareability of URLs. And it's more focused around a systems programming in a way. So like the way you program a Nushift app is more like the way you program like an app that runs on like an operating system. Because I think that there's no reason why you can't do that. Like there's no reason why you like can't have those advantages and also have the ability to share it. And so at the moment, RISC-V, you compile to that, and I'll get back to that. And at the end of the talk, and the hypervisor is written in Rust, which is why this is related to Rust, but there's not going to be much Rust in this talk other than that, sorry. A bit too short for that. Okay, and yeah, I think it's important to have a smaller API than like the web, because you don't need, you can do a lot with, not as complicated of a thing. And yeah, I think having the apps doing their own visual layout is like a thing that is good. It's just like you don't have to like, people developers should be able to do that. Okay, so this is what's implemented. So yeah, there's no address bar yet, but there will be. And this is in Zig, and there's an image embedded inside it. So no, it's not doing text layout, there's just an image. And the whole bundle is like 38 kilobytes actually, including the image, which is, I don't know, it's okay. Okay, I'm just going to go over two key hypervisor app technologies. Okay, the first one is shared memory, but it's not actually shared. So a shared memory capability is a number of contiguous memory pages. So you can have 10 4 KB pages, which is any number, but that's one capability, or you can make it of length 1 if you want. And you can choose with the page size as well at the moment. It just, according to the RISC-V privilege specification, you can choose between 3 page sizes basically at the moment. And so you can, this is kind of like, this like powers everything, and including communication between the hypervisor and the apps. So I was thinking, shared memory or IPC, but the thing is you can have the advantages of shared memory without the disadvantages of like security and memory tearing or whatever. You just, inspired by Rust's exclusivity rules, you just say, well, multiple things are not allowed to access at the same time. So you do that, but you can also remap it really cheaply. So that works. There's no, it's like no copy of the contents of the pages. And yeah, at the moment, app allocate stack. I don't know if it's gonna stay that way, but like again, like the assumption of a stack existing like causes like problems with like I think like glibc has something where it like has to assume that your system stack is a certain size, and that causes, you know, it's more complexity that like why do we have to have that? And you know, Rust, like stackless coroutines with async, like is an example of a programming language which is not based around the assumption of a stack existing. But anyway. Yeah, sorry. App allocated stack, by the way, means that you just have code that makes the system call the allocate stack rather than the loader doing it. Check the time again. Okay. Yeah, deferred calls. So basically, as many system calls as possible should be asynchronous, in my opinion, because I think it's a classic. I think it's a particular kind of thing where, like, a lot of them you don't want it to block the app, and it's a long-running thing. And you allocate a SHM capability for the input to the call, and you allocate one that the system will write into when the task is finished, and that's the syscall that you use to wait for the deferred task to complete. So some of these is just like publishing the app title, like Hello World app, writing, asking it to copy the video, asking it to copy graphics from the CPU buffer, which is the SHM capability, to the VRAM, which is the only graphics call there is there at the moment. Okay, here is some Zig code in a Rust meetup. So this is just, because it does kind of demonstrate a bit like how it works. And this is just some of the main function from that Hello World app. And this is just the first part where it publishes a title and gets the available graphical outputs at the same time, which is the first two tasks that can be executed in parallel. And I haven't included the like structs title task and GFX get outputs task, but they allocated SHM caps and yeah, related stuff. Okay, future of Nushift. So yeah, I'm basically working on the URL thing now. Yeah, it should be as easy to start a secure service serving Nushift programs as it is to start an SSH server. Again, like, you know, it should. That's a statement, and yeah. So I think, I think, you know, you also like literally can't implement TLS like securely if you're not a browser, or like a lot. I think like a lot of other applications that are based on TLS have not gone through all the crap the browsers have gone through, or they've like have to fix a lot of things. So anyway, that's another reason to do it differently. Okay, and the ISA RISC-V stuff. So I think the most common question I get, and you can come up and ask it if you want, is you know, why RISC-V over WebAssembly? And I don't have a good reason. The only reason is because at the time that I looked at it, that I researched it, the RISC-V specification had more features and was more mature and more polished. Particularly in atomics and, well, atomics is not the main one, but environment calls at the time, you know, RISC-V had, and WebAssembly at the time did not. But my original vision was, it took me a while to get to RISC-V because I didn't want to do it. I didn't want to do either RISC-V or WebAssembly. Like the original vision was that it would be x86 64 or ARM 64, and you know, then I kind of, you know, at the time realized, okay, I can't sandbox this. But I think with hardware virtualization, I don't know, I didn't think about it at that time, but yeah, I think you should be able to have hardware virtualization. So, and apps, and that also gives a solution for apps running user apps. Like, you know, you have like a platform, like a software as a service where like users can write plugins that go into your thing. So like with hardware virtualization, we get, at least on x86, we get Ring 0, Ring 3 for free. We even can get nested virtualization for free if we're running on commodity operating systems with hypervisors that support that, which we do. And then, so if you're an app that wanted to be able to sandbox user apps, your app would run in ring 0, and you would run user apps in ring 3, and that's also should be enforced by the hardware and the correctness of the custom operating system you write as a Nushift app. That is it. That's the last slide. And there's the repository, and there's my Mastodon again. Thank you.
Yeah, I'm really interested in how you plan to address these programs. So, like the addressing scheme, this URL scheme. What is it going to look like?
Oh, okay. So I think what I'm thinking at the moment is, it's going to be a different URL scheme. The name of the scheme is probably going to be NSQ. I just think Nushift quick, maybe, and I think an app will be just like, when you click a link, it will go to the Nushift, obviously because of the custom scheme, and I think an app will just be like a binary. Like file, like in HTTPS quick style, and like how hyperlinks will work, if that's going to be a thing. Like if you click it, it makes a system call. Like what system call should we allow to act on a hyperlink? I don't know yet.
What?
Sorry, I didn't know.
What if you don't have the binary? Like it's an app that multiple people are using. So do you have an address for the app that is just out there?
Yeah, I'm not sure what your question is. Like a developer compiles a binary and then like serves it basically over an HTTPS-like server. And that binary like is a web page or like a Nushift page.
Okay, so this would be apps always running on the user's machine.
Yes, but it's downloaded from the network.
Yep.
Yeah.
Cool. So my question basically is, if you think about the web in a more abstract way, you've got media types, right, that describe what the response is. And so like the response can be HTML, and then the browser invokes this HTML routine and displays a web page. If it's application zip, it takes the binary and downloads it and stuffs it on the file system. Have you thought about, like, instead of building a new browser, integrating with an existing browser and giving it a new media type for the kind of apps that you want to build that you cannot express in HTML or whatever other media type there is?
Well, I'm not on any committees that can advocate for that, so I don't know. I don't know if, some existential things I've been thinking about is like, if this becomes a thing and is successful, I think if that happens, then it will somehow light a fire under their ass. But like a really cheap thing that you could do is they could just copy it into their browser. Sorry, does that answer your question?
One more quick question.
Okay, we'll talk after.
Okay.
Maybe an obvious question: why Zig and not Rust for the apps?
Yeah, that's a good question. Definitely we should like add Rust support, and I also think that to just like rewrite that user support code for Rust, I don't want to do like FFI into Zig or whatever for it. I just thought it might be better for binary size and cross compilation, but that's probably not true. But yeah, that's kind of my weak reason.